Hello everyone, in this video I'll cover SQL Aggregate Functions and group by and having clauses. I'll write example queries to demonstrate these concepts and execute those on the Northwind sample database. These are some of the commonly used aggregate functions in SQL: minimum, maximum, count, sum, and average. Aggregate function performs a calculation on a set of values and returns a single value. Now, by the term set of values, it refers to either a column or a list of records from a table. Say, for example, within the Northwind database, there's a table called products where there's a column called unit price. Now, if you want to find out what's the maximum priced item in that product table, then what you can do is make a call to the max aggregate function on that unit price column, and it will return you the maximum unit price. So you can write, say, select max unit price from the products table, and it will return the maximum value in that product table, which is the maximum price in that column. Now, when you do that, by the term set of values, it's referring to a list of unit price within that selected column unit price. So it will look for the maximum price in that set of values, set of unit price, and return a single value. The term set of values can also refer to a set of records, and it can find out, you can apply aggregate function on a set of records. So for example, if you want to know how many products are there in the product table, one way to find that out is to apply the aggregate function count. So count counts how many records are there in a particular column or in a particular table. Say for example, if you write select count all from the products table, what it will do is it will count how many number of rows are there in that product table, and it will return a single value. Okay, so we'll also cover how you can write queries using group by and having clauses. We'll start writing some queries to demonstrate the basic aggregate functions, and then we'll come back here and we'll explain how you can utilize group by and having clauses to retrieve aggregated results based on certain groups. Okay, now what I'll do is I'll write some queries in SQL Server Management Studio and execute those on the Northwind database. So I have the Northwind database imported within the MS SQL Server. So what I'll do is I'll make sure that the Northwind database is selected. For me, I named it as Northwind 2, so I'll make sure this one is selected. And you can see the selected database is Northwind 2. And here, if you expand Northwind 2, you can see that we have all the list of tables. And this is the product tables. If you expand, you can see these are the columns within the table. Now we'll start writing queries to demonstrate the aggregate functions. Now the first one is the aggregate function max. As the name suggests, it will get you the maximum value within the selected column. Say for example, if you want to find out what's the highest unit price of any product in the database, you know that to get the information, we can find that information within the products table in the Northwind database. You can see this is the ERD for the Northwind sample database, and you can see within the products table there's a column called unit price, and we'll have to find out what's the maximum value within this column unit price. Now to get that, what you can do is, so you can write a query, say select all from products, and if you execute this, it will retrieve all the records from the products table. You can see there are 77 products, and we are interested in retrieving the highest unit price of any product in the database. So here's this unit price column. So what you can do is we can write select max, and then we can pass the column name. So we can write select maximum from the unit price column from the products table. If you execute this, you can see that it's saying $263.50 is the highest price item. So if you want to give this result a name, if you want to give the column a name, you can do it by renaming it. So you can write select max unit price as, say, maximum unit price, and if you execute this, you'll see it will now rename the column to maximum unit price. If you want to include spaces within an identifier, you use brackets to implement that. So if you want to include space within an identifier, you can do that by enclosing the identifier within brackets. So if you execute this, you will see that the column name will now include spaces. Okay, now the next aggregate function is mean. Say what's the lowest unit price of any product in the database. So it's easy, so it will be very similar to the previous query. Now we'll do from products, and now instead of max we'll write mean, and we'll do unit price. And if you want to rename it and say we'll call it minimum unit price, and if you execute it, you'll get to see the minimum priced item, which is $2.50 only. Okay, now the next aggregate function is what is the average unit price of products in the database. So you want to calculate what's the average unit price. So again, very similar, you will write select from the products table, and you're planning to retrieve the average of the column unit price. So that way it will calculate the arithmetic mean from all the values in that unit price column. So you can rename it, say average unit price, and you can execute it. So you can see that the average unit price is $28. Now as you can see how aggregate function works, when you applied these basic aggregate functions on the unit price column, as you can see, the unit price column is a set of values, is a list of values where it will include 77 products unit price. So the aggregate function will work on a set of values. It will perform a calculation and it will return a single value. Say for example here, it will work on the list of unit price, and then it will perform a calculation which is the arithmetic mean, the average, and returns a single value which is the average unit price. Okay, now the next one is the aggregate function count. So as the name suggests, it will count how many records are there in a list of records or in a list of values. So say for example, if you want to know what's the total number of orders placed in the Northwind database, so you want to determine the total number of orders placed in the Northwind database. Now if you go back to the ERD, where do you get order information? So within the Northwind database, you can see that customer can place many orders, where you have the order ID, and orders table is related to the order tables, because in an order you can order multiple products. So that's how this is connected. But to get the unique number of order information, this orders table will be enough. So if you can count how many records are there in this orders table, you'll get to know the total number of orders placed on the Northwind database, because order ID is unique. So we'll go back, and we now know that we'll need the orders table only. Orders table include all the information we need here. So we can write, say, select all from orders. If you execute this, it will retrieve all the records from the order tables. You can see there are 830 rows returned. Now, if you want to return that number 830 rows, because there are 830 unique orders within the Northwind database, what you can do is you can apply the count aggregate function and pass all. You know that asterisk is read as all. So if you write select count all from orders, what it will do is it will perform a calculation on the set of records, where the set of records refers to all the records or rows from this result set, and it will perform a calculation which is the count. So it will calculate how many number of records are there. So count returns how many number of values are there in the result set. In this case, the result set is a list of records, a table. So it will calculate how many rows are there. So if you execute it, you can see that it will return 830, which should be the case, because there are 830 records into the orders table. Okay, now how many orders were shipped to Germany? So you are interested in knowing how many orders are shipped to Germany. Now, where do you get that information? Where do we have that ship country information? So again, we can refer to the ERD. You can see that orders table includes ship country, the country where you ship the orders. So ship country is there within the orders table. Now, if you check the values within the orders table and the values within the column ship country, say if you do select all from orders, if you scroll right, you'll get to see there's this ship country. Orders are shipped in different countries, but in this query, for this query, we are interested in counting how many number of orders were shipped to Germany. So what you can do is we can write, say, select all from orders, and we are interested in only the records where the ship country is equals Germany. So we are interested in only the orders where they were shipped to the country Germany. So execute, and now note that instead of displaying those 830 records, it's now only showing 120 records. Why? Because these are the filtered result where you can see that all the orders ship country column value is Germany. So now we have the list of records which we are interested in. Now we'll have to return the count, how many orders are shipped to Germany. So you know about aggregate function count, so you'll use the count aggregate function. So select count all from orders where ship country is Germany, and you can rename it as a number of orders shipped to Germany. It's a long name, but it will be self-explanatory. So if you execute it, you can see that the result is 122, which should be the value. Okay, now the next one is how many different customers placed an order, not including duplicates. So we want to know the unique number of customers who placed an order within the system. Now, where can we get that information? So if we refer to the Northwind ERD, here you can see that within the orders table, we'll get the order information. We have the order ID and order related information like order date, ship date. And the order table also includes the customer ID. So one customer, as you can see from the relationship, one customer can place many orders. That means within this table, there can be multiple records, multiple entries for the same customer ID, because one customer can place many orders. So there can be many duplicates with respect to the customer ID field in this orders table. But we are interested in knowing the number of unique customers which placed the order. Now let's do it part by part. So the first thing we can do is we can write select all from orders, and here you can see that we have customer ID, and here you can see there are 830 rows. Now let's project only the customer ID column. So it will project only the customer ID column, and as you can see there are 6 entries for the customer with ID ALFKI. That means this customer must have placed 6 different orders. But we are interested in knowing the unique customers who placed an order. So in that case, what you can do is you can make use of the distinct keyword, which eliminates eliminates the duplicates. So if you write select distinct customer ID, if you execute it, you can see there are 89 records. That means there are 89 distinct customers who placed an order. You can see there's no duplicate here. Now the final goal is to return the number, how many different customers placed an order. So this query should return 89. Now how can you get that? You can pass this distinct customer ID as the parameter within the count aggregate function. So what it will do is it will count how many distinct customer ID are there within the orders table. So if you execute it, you can see that there are 89 such customers. Okay, now the next one is the aggregate function sum. If you are asked to find out what's the total price of all items in stock in the whole products table, that means you want to know the total inventory worth. So how can you get that information? The first thing we'll have to figure out is where we'll get those information. Will we get those information from a single table or from multiple tables? Okay, so if you check the Northwind ERD, you'll get to see that within the products table we have product information where there's this column unit price and units in stock. That means if you multiply unit price times units in stock, you will get the total price for a particular product, and then you can calculate the sum for all products unit price times units in stock. That way you will get the total inventory price. Okay, now let's write the query to get this information. So you know that we can get this information from the products table, and we need the total price of all items in stock. So the column we are interested in is unit price and units in stock. So if you execute this query, it will project only two columns, unit price and unit in stock. So if you calculate unit price times unit in stock for each of these rows, then you will get the subtotal, which will refer to the total worth of a particular product, and you can apply the sum aggregate function on each of the subtotal for each of the rows, and that way you will get the total worth of your inventory. So if you say, for example, apply the arithmetic operator multiplication on unit price unit stock, you will get the product of unit price and unit stock, and if you execute it, it will get you the total worth of each products. Now you need to find out what's the total price of all items in the stock. In that case, if you apply aggregate function sum on this computed column, unit price times units in stock, so it will apply a calculation which is the sum calculation. So it will apply the sum calculation on these list of values, which will get you the total price of all items in stock. So if you execute it, you can see that the total inventory worth is $74,050.85. If you want to give it a name, say inventory worth, it will rename the column name inventory worth. Okay, now use of aggregate functions in nested queries. Say for example, if we try to find out what's the largest price of any item in the product table and its item number, how can we find that? We want to find out the highest priced item, item number, and the price, the maximum price. So you know how to get the maximum priced item. So you can write select max, and you can pass the column name, say unit price, from the table, say products. If you execute this, it will return $263.50. We wrote this query before. This is the maximum price. Now we are interested in knowing the item number of this particular product. Now how can you get that? So what we can do is we can write another query where we can project the product ID and the unit price of the highest priced item. So you can write select from the products table, and we'll project the product ID and the unit price of the product where this product will be the highest priced item. So you can write where unit price and then we'll use this value we got from the aggregate function queries. So here you can see that we utilized the query we wrote before, select max unit price. You know this query will return a single value which will be the maximum price. So we will use this query result in this comparison. So select product ID unit price from the products table where unit price will be equals the value from this query, which is the maximum price. So it will check where unit price equals maximum price. So that way you will get to retrieve the highest priced item, product ID, and unit price. So this kind of queries are known as nested query or subquery, where this second query is known as the inner query, and this is known as the outer query. In SQL, the database engine executes the inner query first, and the outer query will utilize the result returned from the inner query. Okay, I have another example for you to demonstrate nested query using aggregate function. Say, for example, you want to list the product ID, product name, and unit price for all products whose unit price is greater than the average unit price. So you want to return all products where those products unit price greater than the average unit price. So you know what to do. You'll definitely need the average price from the products table, because you will have to compare each product's unit price with the average price. So you will do select average and you will do unit price. It's a simple select statement where it will return the average unit price from the products table. You can see it's $28 something. Now we'll use this result to compare unit price of each of the products unit price and check whether each of the products unit price is greater than this. If that's the case, we'll project those values only. Now read the query. What we need to project: product ID, product name, and unit price from the products table. So if you project select, we'll do from products, and we need to project the product ID, product name, and the unit price. So if you write this query and execute, you'll get to see it will project all the products in the products table. There are 77 products, and you can see the products unit price are in the range, say 18, 19, 10, 20, 30. These are the different values. This results is not sorted based on the unit price, but you can see there are values within the range $2 and $263, which is the highest price item. It's showing all the records. Now we are interested in displaying only the products where their unit price is greater than the average price. Now what you can do is we can write a where clause where you can say where unit price is greater than, and then we can utilize the result from this subquery. So we can say greater than the result returned from this subquery. Okay, now remember the previous result, it returned 77 rows. If you execute this, you will see we'll get way less result because of this where condition. So it will return only the records where unit price is greater than $28 something. Now if you check out all these values, you'll get to see all the values are greater than $28 something, which is the average unit price. Okay, now there's this part where it says place the list in descending order by unit price. So you'll have to sort this result based on the unit price in descending order. So as you can see, the current result, these results aren't sorted based on the unit price column. You can see there's 30, 40, 97, 31. So it's not sorted in ascending or descending order. So we want to display the information sorted based on the unit price in descending order. So what you can do is we can use the order by clause, and we can say order by the column unit price, and we can use the keyword descending. So that way it will make sure that the result set is sorted based on the unit price column in descending order. So if you execute it now, you can see that the updated result is sorted based on the unit price column and it's in descending order.